Alright, I just wanted to post this real quick update of our prototype of our synchronized clock project. And just to give you an overview of the whole setup here, what I've got is I've got the analog devices EE480 demo board here. You have to have this Blackfin processor card to go with it in order to run its program and actually run this guy. I've got a USB cable going over to my laptop that's powering it and also letting me talk to and control the output settings of this guy. I've got the grounds all connected to a common bus. This is just analog ground. This other white wire here is digital ground, and I have the ground pin going to the PICDEM Net 2 board. So all the grounds are just connected together just to keep them at the same reference. This board here, it's just out of the box with their software, and then this is the 9-volt adapter that came with the other PIC demo from, I don't even remember how many semesters ago in embedded systems. But what I noticed on here was that this LED up here, it's labeled RJ0, and it's just flashing on and off. So I figured, well, why not just use that as my GPIO line? So I had to find it, and so I went and pulled the schematic, and I found that it's basically pin 49. It's the second pin over from the bottom, from the right. So 50 is the last pin on this bottom row, going in order from I think it's 26 to 50. So it's the next one in. You see, I got that gray cable or gray wire connected to it, and I've got it plugged into my breadboard over here. Now on my breadboard, I basically constructed this circuit. Let me just go to the schematic. I constructed this circuit right here, which I believe I shared with you already, but it just simply goes to diode D1 1N4001, and then that goes to a 4.7K and a 33K connected in series. And the top of the 4.7K goes to the FS adjust pin. That was a tricky thing to do because if you see, you can see I've got basically these two resistors. Actually, this one here was just I was playing around. I don't need that. You can see I've just got the two resistors. This one is ground. This is all the common ground point. This is the bottom of the 33K. All resistors and diode, the anode side of the diode is connected together. On the cathode side of the diode is actually connecting to the GPIO. That's that gray wire. Now, the top of the 4.7K ohm resistor is this yellow wire right here. See if I can get in there a little bit better. Now, this part was a little bit tricky because, as you can see, I had to remove a resistor. It's a 0603, very, very small resistor, right next to a capacitor, and then I had to solder that wire on there, and then I anchored it down with some hot glue here so it doesn't rip the pad straight off of the board. But that's really tricky, by the way. So anyways, that is the FS adjust pin, and then what you can see, I actually have this thing running. You can see the oscilloscope here, so it's all connected. That GPIO, it's flashing once per second. It is inverted logic, so when that thing goes low, then this thing goes into high power, and when the GPIO goes high, that'll be the low power state, the low voltage state. But you can see it's definitely working. And I'm not getting exactly the predicted numbers that are on the simulation, but they're pretty close. You know, a little bit of fine tuning, if that's even necessary. And I think we can get that thing to the right dB drop that WWVB wants. Right now I'm getting about, I don't know, 12 dB difference between the high and the low state. But that probably will work. So you can see on the DAC program here, I've got just frequency 0. That's set to 60 kilohertz right there. And that's pretty much all I did. I just turned it on and then bumped this guy up to 60K and it started working. So, I mean, that's pretty much it. Let's see if I can show you just on the schematic of the if I can get it to focus here. You can see, what is that, R4? It's kind of hard to read. R4 is a 6.8K resistor. Got to take that out, but it is right next to that cap, so I left the cap in. It shouldn't hurt anything, so I just left it in there. And that's pretty much it. So that's the overview of of the project. The next step is to come up with an amplifier and get that thing to boost that signal even higher, and then get it to drive some sort of loop antenna. And then once I get Connor's code, then we can actually try to see if we can't write this value into a radio-controlled atomic clock. All right, more to come.